This will be about Pythagorean M-polar interval-valued fuzzy neutrosophic sets that were defined and studied by Pavithra and Irudayam, both from Nirmala College for Women, in their paper from 2025. So this video is almost entirely based on their results, but several other papers on Pythagorean fuzzy sets and their variants are mentioned in the bibliography. Moreover, we made some adjustments and corrections of their previous results, or at least of their initial definitions. You will see this. One disclaimer that is important. In general, in this area of research, we have the following phenomenon, that the structures that are analyzed are both complicated and simple. On the one hand, to describe them, you need many variables, numbers, symbols, and parameters, so they are complex. But on the other hand, their algebraic structure is almost always rather natural and standard in the majority of cases, and this will be true here too. It's just De Morgan algebra when analyzed with respect to the operators of union, intersection, and complement. Be as it may, assume that we have some non-empty universal set X, and that we have three functions, three mappings of the form truth, indeterminacy, and falsity, indexed both with tau, which is the name of our set, and with I, which is the number of the pole. Like in bipolar fuzzy sets, here we have m poles. So m is arbitrary natural number. So perhaps the assumption is that that poles describe some, I don't know, maybe points of view of decision makers, something like this. And suppose that the following conditions are true, that the sum of the squared infima of these functions is not bigger than 1, does not exceed 1, and the same with the sum of squared suprema. Okay, then the object of the final form, and as you can see, with each h in X we associate the following sequence of triples of intervals. So for the first pole we have we have a triple, yes, of truth, indeterminacy, and falsity from infimum to supremum in each case, and the same for every pole, like here, yes, this is from 1 to m. So this object will be called a Pythagorean M-polar interval-valued fuzzy neutrosophic set over X. What is important? The original conditions presented by the authors are both of the form lesser than or equal to 3 here, not to 1. Well, we suppose that this is just a typo. If not, then perhaps it would be a drawback, some disadvantage that should be repaired. So we repaired it and we replaced their original inequalities with lesser than or equal to 1. We would say that this approach is closer to the existing standards, like the paper by Granados on Pythagorean neutrosophic pre-open sets, but we saw many other approaches. In some cases it was lesser than or equal to 2, and there were other solutions analyzed too in other papers. Basically, all the examples that are presented by our authors suggest that the approach that we presented here is correct, lesser than or equal to 1, the sum of squares. Here you can analyze this example. Very simple universe containing only two objects, C and F. We have 3 poles, and here we build an exemplary Pythagorean 3-polar interval-valued fuzzy neutrosophic set. Yes, we evaluated all the membership functions, and you can check this analysis, which is here, to ensure yourself that it satisfies the expected conditions, assuming that there is no any typo or mistake. For example, this triple of neutrosophic intervals that is presented here is not allowed in the light of our definition because squared sums are bigger than 1. Squared sum is bigger. The sum of squares is bigger than 1, of course. Okay? And this is about right ends, but the same can be said about left ends. Okay, as for the inclusion, as always, we should define it. Well, we would say that tau 1 is contained in tau 2 if infimum of truth is lesser than or equal of tau 1 is lesser than or equal than infimum of truth in tau 2 for every pole and for every element of the universe. The same with suprema, but in case of indeterminacy and falsity, the ordering is reversed. Yes. Well, basically, in the original source, this ordering was not inverted. So in each case, we had tau 1 lesser than or equal to tau 2, falsity of tau 1 lesser than, and so on. But we corrected this in the spirit of typical neutrosophic definitions. So now they are more like in the paper by Daly. You can check the bibliography. You can analyze this example in your free time and check that here we presented such an inclusion, yes, that this tau is contained, that rho is contained in tau. We hope that all the calculations are correct. You can check if you are interested. The authors define null, that is empty, set, where for every pole and for every element we have the following triple of intervals: 0, 0 for truth, 1, 1 for indeterminacy, and 1, 1 for falsity, while in case of absolute set we have 1, 1, 0, 0, and 0, 0. Okay. As for the complement, it's standard too. We replace truth with falsity, and in case of indeterminacy, we put 1 minus. Okay. Union and intersection. As you can see, union is defined in the standard neutrosophic sense. This is so-called type 2 inclusion, perhaps. Maximum for truths, minimum for indeterminacies, and minimum for falsities. While in case of this was union, and in case of intersection, we have minimum, maximum, and maximum. Very typical approach for every pole and for every element. So one can prove that all the actions of lattice and then of De Morgan algebra are satisfied. Idempotence, commutativity, and associativity of both operators, and their mutual distributivity, absorption laws, De Morgan laws, double negation, and expected properties of the empty and universal set. But you can check that, of course, as always, the law of the excluded middle is not satisfied. There are two additional operators defined here, sum and product. In case of sum, as you can see, the initial interval is from the square root of this squared, the sum of squares of truths, of infima of truths, minus their squared product to this, where infimum is replaced with supremum. And then we have multiplications of infima, suprema for indeterminacy and falsity. Something very similar in case of so-called product, but now here we have just multiplications for truth and indeterminacy, while this strange construction is for falsities. One could say, you can compare this with other papers on fuzzy, intuitionistic fuzzy or Pythagorean fuzzy sets, that when you calculate the product of two sets, of the sets with itself, then you can denote it as tau square, and this is called concentration and has some practical interpretation as far as I know. And finally, the authors define topological spaces for their construction as families of sets of M-polar interval-valued neutrosophic sets closed under finite intersections and arbitrary unions together with the empty and the universal set. As you can predict, interior and closure behave in the expected manner. Finally, we could say that the paper is inspired by other authors without any doubt. So, for example, these authors described Pythagorean M-polar fuzzy sets but not interval valued, while these authors analyzed interval valued Pythagorean neutrosophic sets. So here you have the bibliography. Some other papers like Irfan Deli on interval-valued neutrosophic soft sets, or Anna Bryniarska from Poland on the N-Pythagorean fuzzy sets. This is interesting because this is the general theory of N-Pythagorean fuzzy sets with their algebra. As far as I know, they are known also as Q-rang fuzzy sets. Okay, that's all for today. Thank you very much for your attention.